Hi, this is Alex from devstories.eu. DeepEval Framework, Episode 12 of 18. Basic synthetic queries generated from your documents are too easy. Modern language models breeze through simple questions, leaving dangerous logic gaps completely untested. To find real breaking points in your application, you need to artificially escalate the difficulty of your test data. We achieve this using evolving synthetic complexity. Standard generation produces simple, direct questions. Evolution mathematically complicates those questions to stress test your system. People sometimes confuse this with altering the underlying facts. Evolving a synthetic query does not mean changing the ground truth. The source data remains exactly the same. What changes is the structural difficulty of the query asking about that data. In DeepEval, you control this mutation process using the EvolutionConfig. This configuration applies specific evolutionary strategies to transform a basic prompt into a multi-constraint edge case. Take a simple synthetic question like, what is the refund policy? It is straightforward, but it is too generic to be a rigorous test. The first strategy you can apply is concretizing evolution. This takes an abstract query and forces it into a highly specific, tangible scenario. Instead of asking for the general policy, concretizing mutates the query into something like, if I bought a red shirt on Tuesday, can I refund it next week? The model now has to map specific user constraints to the general rule. The second strategy is reasoning evolution. This introduces a required layer of deduction. The evolved question forces the model to perform logical steps before it can provide the final answer. Instead of just retrieving a fact, the query might require the system to calculate dates, compare values, or follow a conditional logic chain based on the source text before forming its response. The third strategy is multi-context evolution. This tests retrieval and synthesis by forcing the model to pull answers from disjointed pieces of information. It modifies the query so the answer cannot be extracted from a single paragraph. To succeed, the language model must combine the general refund timeline from one document with specific clearance item exclusions from an entirely different section. When you artificially mutate thousands of queries using these strategies, some will inevitably degrade. An evolved question might become so convoluted that it is genuinely impossible to answer, or it might drift away from the original facts. This is the exact problem the filtration config solves. You cannot allow unsolvable noise to pollute your evaluation dataset. Filtration employs a separate critic model to act as a quality control gatekeeper. It reviews every newly evolved query against strict criteria before it is saved. If a mutated question is logically broken, no longer aligns with the source context, or degrades into nonsense, the critic model outright rejects it. This two-step process ensures you generate questions that are incredibly difficult but still entirely valid. A high score on basic synthetic data proves nothing about your system's resilience. A model's true reliability is only measured by how it handles the intentionally evolved complex edge cases that standard generation leaves behind. Thanks for listening. Happy coding, everyone.